Audio Jungle. Audio Jungle.
Hello everyone, myself Narendra Singh Maurya. So guys, today we'll have a session of equation of motion for steady and level flight. We'll talk about stall speed of the aircraft. We'll talk about the wing loading and like condition for minimum thrust required and minimum power required. So we'll see one by one. So now give a heading: equation of motion. Equation of motion for steady level flight. Okay. Now check. This is the aircraft here. All right. Okay. Fine. So suppose this aircraft is not flying here. We have two conditions. What are the conditions? Condition one is what? Steady, or steady is also called unaccelerated flight. Okay. Second condition, level or straight flight. Hope you understood this. So if I will write the condition or equation of motion, so that time we can take different flight path angle and all, and then for straight and steady flight we can take condition like for steady unaccelerated means acceleration will be zero, and if it is straight flight or level flight then flight path angle we can take it zero. So I'm not going to write that big equation here, just as per gauge point of view we just go the formula directly. What is the formula or what is the equation for the steady level flight, right? So for this aircraft which is flying straight, okay, straight flight we have, and it is a steady flight. So steady means, I told you, accelerated flight. Accelerated flight means what? Unaccelerated flight. Unaccelerated flight means what? Acceleration becomes zero, and straight flight means flight path angle zero. So I can write here, see, unaccelerated flight acceleration. Acceleration A will be zero. Okay. Second, level or straight flight means flight path angle, I can say it is theta. Okay, that will be zero. Theta. Hmm. All right. So that is the basic idea you should have. All right. So now, if you talk about for the steady state level flight, what is the formulation? So for that, we have to go for the different forces, different types of forces or different forces acting on flying aircraft. Now check. This is the aircraft. Okay. All right. Fine. Now this aircraft is what flying here. For this flying aircraft, we'll show the forces, different type of forces acting. So that will be, first one is nothing but, suppose this is the CG, so that weight will be acting here. Obviously, it will be downward. Lift force will be the force perpendicular to the free stream. So if free stream is here, aircraft got flying in forward direction, so free stream will be coming like this. Like this is what free stream. Yes or no? Now I have to say this is the direction of the aircraft, and blue color is the free stream velocity. Alright, fine. So here this is nothing but different type of forces acting. The perpendicular to the free stream will be lift. This is the opposite to the uh, motion of the aircraft will be drag, and here this is what propelling force in forward direction will be thrust. So equation of motion for steady level flight will be what? Thrust is equal to drag and lift is equal to weight. This is the two condition. This is what? Steady and level flight. Okay. Always remember this is what lift, drag force. All you know, it's very basic. First class only I had discussed. Okay, thrust, and this is nothing but weight. So remember, for steady and level flight, thrust is equal to drag and lift is equal to weight. But at the same time, if aircraft is what climbing or gliding, okay, or turning, so that will not be a level flight. Okay, that will not be a level flight. That will not be a straight flight. So that time condition will be changed. That time the thrust will not be equal to drag and lift will not be equal to weight, because it is not a straight level, it is not level flight, or it is not a straight flight, it is climbing or gliding or turning. Okay, but if it is a straight level flight, okay, steady straight level flight, then it thrust will be drag and lift is equal to weight. Hope you understood this. All right, now we'll see what is the stall speed. So suppose aircraft is what flying here, check. For this aircraft, v velocity. So what is the stall speed? Okay, it is denoted by vs. So stall speed, because velocity of the aircraft will be varying. Okay, if during takeoff velocity will be different, during climbing velocity will be different, during cruise velocity will be different, during glide velocity will be different. Okay, during landing velocity will be different. So basically, for the level flight, lift is equal to weight. Okay, half rho v square s into CL. This is the lift formula. I told you, for level flight, lift is equal to weight. Now, if you check that velocity, velocity will be what? 2w divided by rho s into CL. All right. Here you can write 2w in root. No? Check the formula. rho s 1 by CL. So this 2W by rho s, this is nothing but constant. This is nothing but constant. Yes or no? So you can say V is what? V is inversely proportional to 1 upon CL in root. Huh? So if you have CL max, then this V will be min. So what is the stall speed? So minimum velocity, I can say minimum velocity required for flight or to sustain flying condition or flight condition, called stall speed. Okay, called stall speed. So what minimum velocity required? So how minimum velocity you will get? You will get when you will have a maximum CL. You will have a maximum CL. So for maximum lift coefficient, for maximum lift coefficient required velocity to sustain or to maintain flying condition flying condition of aircraft called stall speed. So for maximum CL max or maximum lift coefficient, definitely maximum, if I say maximum lift coefficient, huh? So if this CL is what max, so definitely this velocity will be minimum, and this minimum velocity is nothing but called as a stall speed. Hope you understood. The whole formula I will write. What is the V stall? If you remove this constant, remove this proportionality, the constant will come. And what is the constant? Constant is 2W by rho s. 2W by rho s. This is the one constant into 1 upon L max, or combined, you can write 2W by rho s L max will be the stall. Alright, always remember this is the stall speed. Fine. Now, next is what? Wing loading. Wing loading. Wing loading, it is denoted by small w. What is that? Simply you have seen the formula V is equal to 2W divided by rho s CL. This is the simple velocity of the aircraft. Now this you can write, so this W by S. What is W by S? Weight of aircraft divided by weighted area of wing. No? W by S is denoted by small w, called wing loading. What it is called? wing loading. So wing loading is nothing but W by S. It is denoted by small w. Hope you remember this. Okay, it's very simple but very powerful thing. Why? Because in examination they will say wing loading is this. What will be the unit? Weight unit is Newton. Weighted area is nothing but meter square. So Newton per meter square. This is the unit. So in problem they will give the data like okay the wing loading of the aircraft is suppose 7,200 Newton per meter square. So that time you should know what is the wing loading. Hope you understood. All right. Now, now we'll see like what is the drag polar equation because that one is very important point uh, before going to the analysis of the minimum drag or minimum thrust required. We should know what is the drag polar equation or drag equation simple. Okay, so next heading is drag equation or sometimes it is called drag polar equation. Okay, so what is the drag polar equation? Very simple. So if you go for the drag polar equation, directly I am writing the equation. So drag polar equation is nothing but first we'll write total drag. So main important significant drag is nothing but I can say wait, total drag will be zero lift drag plus lift dependent. All right. So if you write zero lift drag, so it zero lift. So hence you have denoted by D naught. Naught means zero lift. And lift dependent drag, or it is also called, or it is also called induced drag. Lift dependent drag also called induced drag. So it will be denoted by Di. Total drag is nothing but D. So what you got? Total drag is nothing but D naught plus Di. Okay. In coefficient you can write Td is equal to Td naught plus Tdi. How coefficient you can write? You know the formula drag, standard formula, you know half rho v square x into Td. For all the drag, you can write in the form in terms of drag coefficient. Use this formula, and then half rho v square s will be cancelled out. Will be common for all. No? So we will get Cd naught plus Cd. So this Cd is equal to Cd naught plus Cdi. This is the drag coefficient, total drag coefficient. Cd is the total drag coefficient. Okay, I will write this Cd. Total drag coefficient. Okay, Cd naught is the zero lift drag coefficient, also called also called parasite drag. Okay, what is the CDI? Lift dependent drag. Lift dependent. Sorry, I have to mention lift dependent. No? Lift dependent drag coefficient, also called also called induced drag coefficient. All right. Now, so this formula is, now you got CD is equal to CD naught plus CDI. I told you what is the CD. CD is the total drag coefficient. What is the CD naught? It's called zero lip drag coefficient, or sometimes called parasite drag coefficient. Okay. Now, and CDI is the lip dependent drag coefficient, also called induced drag. So here we have CD is equal to CD naught plus CDI. This CD naught plus CDI also you can write KCL square. Okay. So again, I will write what is the mean of so this CDI is what relates to KCL square. So CDI is the induced drag coefficient. So K will be what? Lip dependent drag coefficient factor. So I must write this. K is nothing but lip dependent drag coefficient factor, or induced drag coefficient factor. That is the K. And what is the magnitude of K? It is 1 upon pi EAR. Pi is the constant, 22 by 7. You know that. What is E? E is nothing but post-wall efficiency. What is that? Called post-wall efficiency. And that post-wall efficiency will be changing. Okay. It depends on the design of the wing. It is rectangular wing, swept forward wing, swept back wing, okay, elliptical wing. Based on that, you will have a value of K. Hope you understood this. And what is AR? It is aspect ratio. What is the aspect ratio? B square divided by S. What is B? Span. Span is square divided by area of wing. Hope you understood. Okay. All right. Now, so now let's suppose we have a rectangular wing. Just for example, so if you check the rectangular wing, so this is what is span, yes or no? And area of the wing will be S. So S is the weighted area of wing, and here this length will be called chord. Okay. So span will be denoted by span denoted by B, and C is the chord. Chord will be denoted by C. So what will be the area? If it is rectangular, so area will be what? B into C. Yes or no? So what will be the aspect ratio? Check previous formula. It's a span square B square by S. S is nothing but B into C. So for rectangular beam, what is the aspect ratio? It is B by C. Similarly, for different type of the wing, aspect ratio will be changing. Swept forward, swept backward, elliptical. For all type of the wing, aspect ratio will be changing as well. That's the reason it's a designing parameter. No? Like span, area, these are the designing parameters. So aspect ratio will be changing, it will not be constant, so don't worry, they will give the value. Okay, they will give the value directly, they will give value, they will say like this is the span aspect ratio. Hope you understood now. So we can say now drag polar equation, now we are aware with that, which is nothing but CD is equal to CD naught plus KCL square, where CD naught plus K is nothing but 1 upon pi E AR. Okay, this is what CL square. So this is what drag polar equation. Okay, most of time they will give, most of time equation they will give in this format. No? Like they will give 0.005, okay, plus 0.016 CL square. So you have to compare this. So if you compare, because in numerical you need to solve this. So this box you have here, okay, you compare this. If you compare, then what you will get? CD naught you will get 0.05 and K you will get 0.01. So data indirectly they have given CD naught and K. So if you know the standard equation, then only you will be able to compare, right? Otherwise, if they will give numerical, in numerical, if they will give CD is equal to 0.05 plus 0.016 CL square, then how you will use this equation? For that reason, I have explained here what is the drag polar equation. So drag polar equation is CD naught plus KCL square. You compare it. CD naught is 0.05 and K is nothing but 0.016. Okay, so today up to here only I have to cover, and now next class will go for the minimum thrust required. So that is very important topic. So for that reason, I will take it separate, and similarly minimum power required also. So for today, I think this is the topic. Hope you understood this. All right. Thank you all. Thank you so much.